right, we're going to start with the first round of lightning talks. 5 minutes, no questions. Yeah, let's get started.
Yeah, hello. So the talk is about hopefully DRM DisplayPort framework. Some time ago, Maxim Ripard started the HDMI connector framework, which helped us to clean up stuff for the HDMI. And during reviewing some of the patches on the DRM, during reading the link trading code for the third time, I thought that maybe we should pick up what Thierry has tried to do a few years ago and try to do some more generic code for DisplayPort. And yeah, there is actually a definite need for that, because you can see the drivers which do something sensible for DisplayPort, other than just talking to the firmware like some analogous code. And you can see a lot of them try to do link trading. Yeah, that's obvious. How many of them do know that we can do simple link trading without OX transactions? Very few. And how many of them know that between the DisplayPort host and the DisplayPort rigs can be LTTPRs, so link trading, transparent file repeaters? Also very few. And you can guess how many know that to prevent issues with the LTTPR, you should first check them and not the actual DPCD. I think only one. And that's not even the driver which I care about. The same goes to other features. Yeah, I really just sketched what was sensible. Like how many hosts know about the EDP or try to do EDP? A lot. How many of them know that not all of that the EDP has extra registers for link rate? Half of them. How many of the DisplayPort controllers know that there is no need to implement HDMI codec operations directly? Also very few of them. So I proposed a hackathon which was accepted, and I don't expect to write a lot of code, but instead I would really like to collaborate and to hear which parts of the standard, which are the pitfalls. I have some code written which somewhat works, but I definitely want to hear and exchange all the pitfalls, all the issues like, yeah, you should not be talking to DPCD before talking LTTPR. Oh yeah, on this platform the EDP does not work this way. Oh yeah, by the way, with this dock there was an issue with link trading, so we had to implement it in some other way. Because in a few weeks and a few months, I totally hope to be able to do the something more generic that we currently have. We have only very low-level ops in the DRM display helpers. I hope to do one step further. And yes, each driver has their own specifics. That's why Thierry's code was rejected. But I still hope that after several years after that attempt, we have somewhat more understanding of what the drivers need and what the drivers do not need. And I hope that we can have some more generic framework letting drivers not to implement yet another DisplayPort link trading support when somebody else comes with the yet another DisplayPort driver. References, and thank you, and I hope to see some of you on Wednesday and to discuss DisplayPort. I hope that was...
Hi. So just a quick update. I will try to cover everything. To give some context, all the SoC vendors have some kind of MPUs in their latest SoC, some of them, and they are normally used for vision and some speech recognition. Nowadays, of course, they are moving to LLMs, but hardware always lags behind functionality. And you know about the drivers axle subsystem is already there. for a few years now, but the initial drivers were for cloud and desktop and so on. But we have been seeing since a year and a half the first work in mainline for edge devices, embedded and so on. That was Etnaviv. So it's in drivers GPU DRM because it already existed, and well, we based on that. What has happened since the last XDC? We added support for another NPU to Etnaviv. It's pretty popular. It will be around for a long time, so it's quite interesting that we are there and it's being used in products based on mainline, and we added more operations that allow us to accelerate new models. We'll have to keep doing that. We have a new driver. It's not in mainline. It's in DRM Mix Next, so hopefully, if nothing happens, it will be in Linux in the next Linux release. It supports one SoC, but that hardware is used in several other SoCs from the same vendor, so hopefully it will be easy to add the support for those. There are no programmable cores in it. It's all fixed function. It's really fast for what it can do, and what it cannot do, well, has to be done on the CPU, GPU, etc. And well, there's 3 cores which are identical, so it's quite interesting that we can load balance among them and has some performance implications there. We have another driver which is also used on embedded on the edge. That's ARM's ethos IP, and we already have the kernel driver in LTML under review, so if it interests you, please look at it and send comments. We are supporting the U65 in one specific SoC, which is the IMX93, but there's hardware coming up with newer versions. We will want to support that. ARM is involved in that, so we didn't have to reverse engineer it. We have a documentation very good at that, and pretty good source code we can base. It's out of 3, so it's not suitable for mainline, but we are working on that. No programmable cores either, so same thing basically that the Rockchip one. Now what's coming next? I'm working on PyTorch executor support, which is more commonly used nowadays for LLMs and so on. So that's pretty interesting in itself. We are looking at using NEAR to implement in a more efficient way some optimization passes and share code among drivers. I'll be having a talk tomorrow about this. And there's a new driver that I will start working very, very soon, and hopefully it won't take me that long because I will have documentation and source code for this. And there's another one which recently has been, they have told me that they are interested in me doing that. So hopefully we'll have more drivers for embedded in mainline. And well, no time for questions now, but we have an RC channel, and just grab me for questions. So thank you.
Hi, I'm here to talk about old GPUs. So for context, this is about the very first GCN GPUs that were released about 10 years ago. So I think the first one was released in like 2013, but they kept selling and making new cards out of those chips until up to 2019 or so. So if you have one of those GPUs and you plug them into your Linux computer, what actually happens? Does it work, is the question. So we actually have 2 kernel drivers for those GPUs. We have Radeon, the old driver, which is nice, stable. It is the default driver. Unfortunately, it doesn't support Vulkan. So if you actually want to play games on Linux, these days it goes through Vulkan, and it's not really supported with this driver. So you would like the new one, which is called AMD GPU, but it's not feature complete, it's not the default, and well, it was never quite finished. So I was going to ask myself a question, like, what would it take to make it the default? What's missing? And why even work on this at this moment? So my goal is to actually make it useful for games. If you're a gamer, you should be able to play a game on this. You should be able to use the display features in your hardware. And some people are asking, okay, why don't we just implement the code to kind of work with the older driver? And the reason for that is because in order to do that, we would need to turn it into the new driver, which, well, the good guys here, they already did that, so like, come on. It's better to just invest our time in improving AMD GPU and the DC display driver. And finally, these GPUs are really old. So why after all this time? And my main reason for that is I always wanted to learn a bit about kernel development. So why not? And the other reason is usually if we have better hardware support, it means the drivers in general become more stable. So last XDC, I asked Alex, what actually needs to be done? And it turns out it's not that much. We just need to fix some missing stuff. So mostly just support for analog connectors. I don't know if anybody here uses it, but probably not. But it's missing from this driver. And from even older chips, they are missing the video coder support. So it's just two things. Come on, how hard can it be? So I said, okay, let's actually just do it. So at first, I plugged in this GPU as like a secondary GPU, and I just added this code. And then it occurred to me, okay, but what if actually I just use not the secondary, but what if I use it as a primary GPU? And then, well, for the newer ones, this was not that much trouble, but for older ones, it was not the best experience, and I'd say most of them just didn't work. So, well, with some help, I actually found out how to diagnose these issues. I'm not gonna tell them in detail at the moment because it's just a lightning talk, but if anyone wants, they can read the slides. The point is, eventually, it started working. I wrote some patches, and it actually turned out that some of these were actually helping new GPUs as well. So it's not just wasted time on old hardware, but rather it benefited other things. And it's kind of the same story with Mesa, where we have these two drivers, Radeon SI for OpenGL, RedV for Vulkan, and both of these drivers already support these GPUs and have been for a long time. But is it really useful if the kernel doesn't actually support RedV, for example, by default? So I was actually looking into, okay, what kind of issues do we still have with them? And by now, thanks to Martin's efforts, we actually have all GPUs in the CI. So we test them for regressions, and hopefully we can avoid regressing them in the future. And mainly we want to focus on stability, not really new features, only when necessary or feasible. So not everything is feasible, but we try. And the point is that if you troubleshoot issues on old GPUs, you often will find problems that affect new GPUs as well. So it's, again, it's a useful thing. And well, what is this actually useful for, or who would use this thing? And well, actually you could use this for many things, like if your main GPU is broken, you have an old one in the drawer, you need a working computer, so you just grab that, you plug it in, and you want it to work. Or when you just need to connect more displays, or when you want to play with Linux on an old PC, or when you live in a poor country and this is what you can afford. So mainly, you can still use these to play games, but they are held back by small amounts of memory. So some of the new, like the bigger chips, they can actually play real games that people would play. The other ones would play like games from 10 years ago. Some maybe not even that. Anyway, most of the code has been accepted. There are still some code on the mailing lists or MRs. and hopefully it will make it into Linux 6.18 and the next MISA release. We still need to find some solution for VCE1 if we want to enable it by default. So basically that's it. And if you want to help and you have an old GPU, just play it, report whatever issues you find on it. And I just wanted to say a quick thanks to all of these gentlemen who helped with this effort. Thank you.